So as I said before, the behavior of ketones and aldehydes in these reactions is identical, and the product that we make is dependent upon the structure of the amine and whether it's primary or secondary. So if I look at the following reaction of benzaldehyde with this primary amine in the presence of trace H3O+, this is the product that I isolate out of that reaction. In this reaction, identify the carbon where all of the chemistry happens. It's this carbon right here. That's the original carbon of the carbonyl. That's the carbon where the tetrahedral intermediate will form, and that's where all of the chemistry will happen. Make sure you can work through the mechanism on your own. And the second reaction here. This is the formation of an enamine. I have a ketone that undergoes a reaction with a secondary amine in the presence of trace H3O+, and I get an enamine as the product of my reaction. Can you identify the carbon where all the chemistry happens? It's this carbon right here. Make sure you know how to work through this mechanism on your own. Be sure you can go through both of these mechanisms on your own. So we can see how this enamine product forms. We have a symmetrical ketone, so when we do the elimination, it can happen from either one of these carbons that are alpha with respect to the ketone. This is the alpha carbon with respect to the ketone. This is another alpha carbon with respect to the ketone. This is the beta carbon. This is another beta carbon. In this case, we have a symmetrical ketone. So that in this reaction, both of my alpha carbons have 2 protons, so both of my alpha carbons could participate in the elimination in order to give me this product. But if I had a ketone that was not symmetrical, if I had a ketone like this one, and I treated this ketone with a secondary amine, like this one, in the presence of trace acid, what would be the product that I get out of the reaction? Where would that double bond form? Do you know? In this case, the double bond would form there. This would be the major product that I isolate out of the reaction, and this is the product that's consistent with Zaitsev's rule. Remember that Zaitsev's rule tells us that we're going to form the more stable or the more substituted alkene as the product of this reaction. What would happen if I had a ketone like this one? What if I treated this ketone with a secondary amine and trace acid? What would be the product that I get out of that reaction? Pause the video and predict the product. In this case, the product that I get out of the reaction, in this case, I will get 2 products out of the reaction. I will get this product here plus this product here. These 2 products are different, and because my alpha carbon in each case has 2 protons, I don't have a difference in the substitution of the double bond, so I will see both products form out of this reaction. On an exam, if I were to ask you to predict the products of a reaction like this one, you would be expected to predict both products out of this reaction. So remember that these are reversible reactions of ketones and aldehydes. So in the same way that we can take a ketone or aldehyde and make an imine or an enamine, we can also go in reverse. We can take an imine or an enamine and we can get back the ketone or the aldehyde. So if I have an imine like this one, and I treat this imine with H3O+, so some kind of acid, The product that I get out of this reaction is a ketone and an ammonium ion, like this. The mechanism for this reaction is going to be a part of your homework assignment, but I want to make sure you understand the first step of the mechanism. And that is, if we have this imine under acidic conditions, there are a few things we know that are going to help you. The first thing that you know is that a nitrogen is a good base. So that means that the nitrogen is going to be capable of picking up this proton. We also know that this structure has resonance stabilization, where we can pull the electrons from this carbon-nitrogen double bond, give the electrons to the nitrogen, giving it a formal charge of -1, keep the positive charge on the carbon, and under acidic conditions, we're going to fix that negative charge first through the protonation. So in the first step of this mechanism, you have some flexibility as to how you show it, but either way, you're going to show that nitrogen protonating in the first step of the mechanism, like so. And what you get out of that process is this. Now, if you recall from the mechanism for the formation of the imine, we saw a structure very similar to this in the second to last structure that we drew in our mechanism. So we'll see all of the structures that we saw in the forward reaction, we'll see all of those structures occur in the reverse reaction as well. So this mechanism will be a part of your homework assignment. Make sure you keep in mind that all of the chemistry is going to happen at that carbon of the imine and that carbon of the ketone. If I have this enamine and I put this enamine in the presence of acid, H3O+, the product that I get out of this reaction is going to be a ketone and an ammonium ion, like so. Now, just like the previous mechanism, this mechanism is going to be a part of your homework assignment. So make sure you can work through this mechanism, but I do want to make sure you understand the first step of this mechanism. And in the first step of this hydrolysis mechanism, one of the things that I want to make sure you realize is that this structure has resonance. I have a resonance structure where I can push these electrons from the nitrogen towards the carbon, and I can pull the electrons in that double bond out to that carbon. When I look at the resonance of this structure, I see that I have electron density at this carbon, and I have positive character at the nitrogen. So what that's going to mean for me is that's going to mean that this carbon is going to be where I have my highest electron density, and this is going to be where I pick up that proton first under the conditions of this reaction. This is an acidic reaction, so I have a lot of protons floating around in my solution, and again, I have very good electron density at this carbon, so I'm going to pick up the proton in the first step of that mechanism at that carbon, and that's going to give me this intermediate. When I see this intermediate, I know that I have an additional resonance structure where I could pull the electrons back to the nitrogen, and that would give me a structure that looks like this. And I'll let you continue with the rest of the mechanism on your own in your homework. Remember that these mechanistic steps are reversible. Also remember that in this mechanism, all of the chemistry happens at that carbon of the enamine that becomes that carbon of the ketone.